Welcome back to the Demo Zone, presented by Composites One and the Closed Mold Alliance. What we're demonstrating is we're going to be infusing this carbon fiber UAV Wingskin. So this is a UAV. It was a lifting body, and so it's got a kind of a strange airfoil shape here. But the engine would be at this location up here. It's propeller driven. So this would be either the top skin or the bottom skin of the wing. So with the vacuum infusion process, if you've been watching some of our demos, you can see all the materials go in the mold dry. So we have our dry carbon fiber already in the mold, but we still get, once it's infused and everything, we get similar fiber volume content and void content as prepreg or other processes as well. So we already have the carbon fiber in here, but I want to back up a step and talk about how we're going to get the part out of the mold. So we have to do some special preparation to the mold surface to be able to release the part, get a nice cosmetic finish, and make sure that our tool doesn't get damaged. So I would like to introduce Russ Powers from ChemTrend to tell how this mold's been treated.
In aerospace, typically, they don't use semi-permanents the way they're meant to be. Their thought is that a gallon of mold release costs less than a stuck tool. So we're going to put it on every time. And not only are they going to put it on every time, they're going to put on multiple coats. And that's when you get buildup, and you actually get, if a little bit is good, more is better is not the case. You don't want buildup on your molds because you can get poor release, you can get transfer, you can have problems of subsequent coats wetting out on the mold. So since the aerospace industry has typically not used semi-permanents the way they're designed to, we developed a product that is sacrificial in use, that you apply one coat every time.
After we applied the mold release, sometimes we would start with an in-mold coating to give us a nice cosmetic surface. Since we're doing a demonstration, we actually went right to the mold surface today, and ChemTrend's mold release is going to help us release the part. The next thing we did is we laid in the dry carbon fiber fabric. You can see the roll right down in front of us next to the screen. And so to talk more about the carbon fiber reinforcement we're using today is Mike Ditzler from Vectorply.
Thank you, James. My name is Mike Ditzler. I'm a Southeast Region sales engineer for Vectorply Corporation. Vectorply manufactures a complete line of composite reinforcements, primarily stitched non-crimped fabrics out of carbon fiber, aramids, as well as e-glass. The material we're using here today is an 18-ounce material. It's our CQXI 1805. So this is an 18-ounce fabric. It's quasi-isotropic. And since we're doing a vacuum infusion process here, it's got our micromesh material included in this fabric. In addition to the carbon fiber material, where we're using 3 layers of the CQXI 1805, we're using some of our Vectorfusion consumables here. This is a line of materials we came out with about a year ago that was in response to market demand for labor reduction when assembling vacuum and resin distribution manifolds. So we're using 3 different products on this part. Around the perimeter here, our vacuum manifold, you can see this is our Vectorvac Red, which is basically a spiral cut tubing here on top, wrapped in an easy release peel ply.
So now what we're doing, this blue material going down, is our flow media. And so to tell you more about some of the process materials we're using, including the Infuply flow media, we have Kevin Jackson from Aerovac.
Aerovac have become part of the C1 family as of March this year. We have a number of manufacturing facilities around the globe. Infuply is a combi product. It consists of a knitted woven mesh and a release film, a perforated release film. So as you saw them putting it down there, we're putting down 2 layers at the same time, so energy efficient. We make a range of other materials, bagging films, release films, peel plies, sealant tapes. The bagging film that we're using at the moment is 200G. It's a bagging film that'll be good up to 120 degrees C, 250F. So it's perfect for an application like this. and they'll be sealing this to the edge using a sealant tape, our 2042 product, which we've been using throughout the week. As you watch them put the pleats in, little time consuming.
So one of the things that Mike talked about is we're going to be doing a branch feed here, and so you can see the under the bag, the feed lines are set up so we have one main feed line that we're going to connect to the resin pump, and then we have branches coming off. And so that's going to allow us to feed this entire part with one feed point. In this case, we don't have to time the opening of any of the lines. We just start the pump until the part is full, and it'll be infused. So while we're bagging the part, I'm going to let Drew Simmons from MVP tell us a little bit about the equipment we're going to use today to inject this part.
Great. Thanks, James. My name is Drew Simmons. I'm a sales manager with Magnum Venus Products. Today we're going to be using our Innovator 2 injection system set up for polyester and vinyl ester resins. You can see our control box up here. Some of the features on here, we have our pneumatic stroke counter. Basically what this is going to do is we're going to preset how many strokes of resin, catalyzed resin, needs to go into the tool. We'll set that, hit start, inject the resin. We can walk away, go prep the next part, demold the last part, do something else in the shop.
We're going to get a chance to see the pump operate as soon as we get the bag sealed. One thing you'll notice with the infusion process is the bag is much larger than the actual part. That's because we're working with a flat piece of film. I'm not sure that if we mentioned it already, but this film is 3 mils thick, so it's pretty durable. It's really good for the infusion process. One of the reasons it needs to be larger than the part, typically, depending on the part geometry, we'll run 25 to 30% larger, is we need to make sure the bag has sufficient slack so it can go around all of our process materials and conform to any geometry of the part. So the pleats they're putting in, you can see there's various sizes. So that's going to take up all the slack. It's going to make sure the bag is sealed and airtight. So you can hear the vacuum pump behind me. This is an oil rotary vacuum pump from RTM North, and it has 2 reservoirs for so we can have good initial drawdown of the part. You can see the bag will start pulling down as we're pulling vacuum. We have a gauge so we can tell what our vacuum level is, and the vacuum pump is actually connected to a resin catch pot. So now that the bag's pulling down, they'll go around the perimeter and check for leaks. I think I hear one right here. So Mike has performed a vacuum drop test to see if we're losing any vacuum level. He says we're good to go.
So what I mentioned earlier is we were doing a recirculation of the material, get everything flowing, make sure everything is flowing well.
So now Mike's going to tell us a little bit about the resin flow.
Yeah, so you can see here the brown 2.0 material. You can see as the resin came in this tube here, it distributed quickly along the long axis of the part. And now it's starting to bleed out into the laminate. And you'll see now the resin is starting to transition from the brown material into our branches here, which is the orange 2.0. So like James mentioned, we could have done a sequential feed with this kind of part. We probably would have had one main feed line down the center, and then probably would have had one additional line to either side. So instead of having one injection port with this feed line strategy, with a sequential feed line, we would have had 2 additional feed points going into the part. And anytime we penetrate the bag and have a through the bag connection, it's just a chance for it to leak. It's additional hoses, it's additional process materials. So this type of feed strategy can really cut down the labor involved with this type of infusion. We've got a primary resin break here, where we've actually ended the Infuply flow media before the edge of the laminate. And I was talking about how carbons can be difficult to infuse and achieve full penetration of the resin through the laminate stack. So by having this primary resin break, the resin will race up to the end of the flow media, and it'll really slow down and give the other areas of the laminate a chance to catch up. And then instead of racing all the way to our vacuum line, the resin will have a much better chance of penetrating through the entire thickness of the laminate, making sure we have full wet out and good surface cosmetics on the other side. We also have a secondary resin break here, thanks to the Vectorvac Red, that after the break zone of the flow media, then we have the edge of the laminate, and then we have a few more inches before we have our spiral cut tubing in the Vectorvac Red, which really helps prevent any excess resin from getting into our catch pot. So really, at the end of the day, ideally, these lines here that form our vacuum manifold to our catch pot, we could reuse them because we don't expect to get any resin in these lines at all, basically.
Yeah, you can see the shape of the flow front. It's a very, very controlled flow. We could scale this up to a much larger part. So one of the things we offer with Composites 1 and the Closed Mold Alliance is we offer assistance if you're implementing a closed mold process to come work on site at your place